Hey PCH, it's Mr. Filson. And so on Friday during class, you guys all completed a Desmos investigation into transformations of functions. And what you saw was that you had some function f of x, which was this blue function on your screen, and there was some transformation happening to it. In this case, we had some number being added onto our function. Another example of a transformation was like, okay, what if there's something being added or subtracted to our x value inside our parentheses, right? And once you kind of messed around with that, moved the slider around to see what the effect was, your job was to kind of summarize your thoughts on that transformation. And so what I want to do now is go ahead and kind of sum up what we discovered during this investigation. And so in your OneNote, there's a tab titled Notes 1.1. If you need that for any reason to help frame your notes, go ahead and you can take notes on there. But I definitely recommend kind of creating this table in your notebook. And so let's talk about this first transformation that we saw in our investigation. And it was some value being added to our function. What you guys noticed was, hey, like if we have something being added on, it's going to shift our function vertically. I want to push you one step further and say, hey, yes, it's going vertically, but can we be more specific? What happens when our k value, or when the number that's being added onto our function, is positive? And what is the effect when that value is negative? What you should have noticed is that if our k value, or whatever's being added to our function, is positive, our graph is going to shift up. And if that value is negative, it's going to shift our graph down. And so if we're looking at an example, for example, like this first problem here, we are going to talk more about this looks like, but we see that there's a +4 on the end of this function. What does that tell me? It tells me that this function has been shifted up 4 units. Every single point on this function has been shifted up by 4 units. Excellent. Let's go ahead and talk about the next transformation. And that was if we had some value being added or subtracted to the x inside our parentheses. When you slide this slider around, you'll notice, hey, now our function's moving from side to side horizontally. So this is going to be a horizontal shift for us. Something that's a little bit tricky here is that, hey, if we're trying to think about when h is positive or negative, like which direction we are shifting horizontally, I want us to pay attention to what's here. So right now it says that g of x is f of x minus h. And so when h is a positive 1.4, if we were to write that in our function, that would show up as f of x minus 1.4, minus h minus 1.4. And so whenever we have x minus some number inside our parentheses, that is when we are going to be shifting horizontally to the right. If our number is negative here, so f of x minus h, f of x minus a negative 2.35, that becomes plus a positive. So if it would say f of x plus 2.35 in our parentheses here, that's when we're actually going to be shifting to the left. We'll talk about an example of this in just a second so that you can actually see this effect. But I really wanted to point this out for us because it's the opposite of our vertical shift. If we had a positive k value, we are shifting up. If we have a positive h, x plus h, we are not shifting to the right, we are shifting to the left. You can see those nodes summed up here. I want to show us a quick example real fast. Again, if we're looking at this function here, this square root function, we see that there's something happening inside or underneath the radical, with our x. It's x plus 1. That means that our graph is going to be shifted to the left by 1 unit. Same thing here with this first function we talked about, this rational function. There's something being added or subtracted to the x. In this case, we have x minus 2. That means that our graph has been shifted to the right 2 units. All right, moving on to our next transformation, which is if we have some coefficient, some number that's being multiplied by f of x, what effect does that have on our graph? You'll see I could kind of understand if this was difficult to put into words about like what is happening here. But this is what we call a vertical stretch. Essentially, like if the a value is greater than 1, it is being vertically stretched. If the a value, you notice, is between 0 and 1, our graph is being vertically compressed. So it's being like squished against that midline there, which in this case is our x-axis. And so that's the effect that our a value is going to have on our function. And you can see those notes here. Again, if our a value is greater than 1, then our function is being vertically stretched by a factor of a. And this is important for you to write down like word for word, because on Monday, we're going to be talking about how we can describe transformations of functions in writing. And this is how we are going to write any vertical stretch or vertical compression if a is between 0 and 1. And so again, another example, we'll look at this second function here. We see that our function is being multiplied by this coefficient of 2. And so what that tells me is my square root function is being vertically stretched, because a is greater than 1, by a factor of 2. And we'll talk about what that looks like when we're graphing it in a little bit. But just to talk about it so you can see what that'll show up as when we're looking at it in a function, we can even look down here at this quadratic, and we see that our factor is 1/2. And so this quadratic is being vertically compressed by a factor of 1/2. All right, let's continue this conversation for when a is negative. When a is negative, let's see what we see. If our a value is -1, I think this is a really good example of how you can see that our graph is perfectly reflected across the x-axis, right? When we had a maximum on our parent graph, now that is a minimum on our transformed graph. Our graph has been reflected over the x-axis. And so I want to show us one more example of what that looks like. So here we have our parabola, y equals x squared. What happens when our a value, which in this case is 1, like we do have an a value, but it's just 1, so we don't write it. When that a value is negative, like we see in this function here, what happens to our graph? It's reflected over the x-axis. We will reflect that in our notes chart right down here. Now there's one more transformation that I want to talk about, and that is, okay, what happens if there's a negative inside the parentheses with our x? If the negative is being directly applied to our x and not just f of x, which represents y. I want you to make a prediction based on what we just talked about, in that a negative f of x is a reflection over the x-axis. What do you think f of negative x is going to, what kind of effect is that going to have on our graph? I'm hoping that you actually took the time to think about this, and I'm really hoping that you're like, you know what, I actually want to play around with some graphs. So maybe you tried graphing an example to see like what happened. And so here I have graphed y equals the square root of x, one of our parent graphs. Let's see what happens when we throw a negative in there underneath our square root with our x. Hopefully you came to the conclusion that, hey, if it's a negative a value in front of our function, that's going to reflect it over the x-axis. But if there's a negative within our function, if you want to think about it that way, or in this case underneath our radical with our x, that's going to reflect this over the y-axis. And you will see that in our notes here as well, that f of negative x is a reflection over the y-axis. One more example. If we're looking at this here, y equals negative 3x cubed minus 2. What effect is this negative sign right here going to have on this function? All right, before we get into some examples, I want to get into talking more specifically about how we would graph an a value, which again is going to be that coefficient out front of our function. In order to be able to understand this pretty well, you need to have a very strong understanding of parent functions and their key points, which we kind of discussed a little bit during class on Friday, but I feel like I did not do a good job as your teacher as getting into as much detail as I should have. So I decided to go ahead and make another video that is on Edpuzzle that is specifically talking about parent functions, graphing them, and talking about their key points that we will be transforming when we do examples of transforming functions. So I highly recommend watching that before you finish the rest of this video and go into doing examples. So pause this video and head there now. Highly recommend watching that as support. Okay, assuming we're feeling good about parent functions and key points, I want to talk about how to graph an a value. And so normally, right, if we're looking at just y equals x squared, which is going to be this red graph here, we know we have a key point at 0, 0. We have a key point at 1, 1, and I'm just going to focus on the right half of the graph here, excuse me. And then of course we also have a key point at 2, 4. When it comes to graphing your a value, I like to think of this rule called the one space to the right, or one unit to the right rule. Normally, again, our key point when we go one unit to the right is 1, 1, but we notice that if we graph our function with an a value of positive 2, which is this blue function, now that key point is at 1, positive 2. If we were to look at this graph, and I'll pull it up here for us to see, at an x value of 2 for our blue graph, instead of 2, 4, now we're at 2, 8. I'll kind of like graph it up here. This will be 2, 8. This is 2, 4. And so how do we think about actually making sure we understand the effect that this a value has on our graph? Well, if you know the key point and you know the y value of that key point, in order to graph the transformation with this a value, you're just going to multiply your original y value by whatever your a value is. So 1 times our a value of 2 will give us our new y value of 2. Move another unit to the right. Instead of 2, 4, we're going to multiply our original y value of our key point from our parent function by, again, our a value. 2 times 4 is going to give us that new y value of 8. That's how you're going to graph your a value whenever you have it. A few more examples for us. Here we have y, whoops, that's the highlighter. Let's change that. We have y equals 1/3 x cubed. Normally, our parent function y equals x cubed would have a key point at 0, 0, key point at 1, 1, -1, -1, etc., etc. Let me write that for us. And so again, we are going one unit to the right to find this key point, 1, 1, looking at what that y value is, which is a positive 1, and we are multiplying that by our a value. And that's going to give us our new point, again, at the same x value, but instead of being 1, 1, now we're at 1, 1 times 1/3, which is just 1/3, and that is the point that is graphed here. PCH, that is the end of these notes. Have a wonderful rest of your weekend, and finish the video to find out what your homework is.